All right, so today I'm giving you a little overview of the law of sines and the law of cosines, just in case you're a little still confused on it, need me to go over it again. Maybe your class was disruptive, sorry, and you want to figure out how to do this at home, because you can watch me at home. Yay! All access Mrs. Lunch. Might want to have a calculator. Doesn't have to be this giant calculator. As long as it's got the sine, cosine, and tangent functions. So, okay, let's get started with the law of sines and the law of cosines. It can be used to solve any triangles that are not, that's important, right triangles. You can just use SOHCAHTOA if they're regular right triangles. So, you're going to let triangle ABC be any triangle with A, B, and C representing the measures of sides opposite the angles, while the angles have measures A, B, and C respectively. Then the following is true. Basically what this says is, and this is going to be for all triangles that we're doing today, that you've got a triangle, not a right triangle. We'll assume that those lines are straight. The vertices are the capital letters A, B, and C. And the sides are the sides opposite. So little a is the side opposite big A. Little b is the side opposite big B. And little c is the side opposite the angle C. So this is going to be the model for all the triangles in this section. I think you might find the picture a little more helpful just because I know most of you are visual learners. So let's do some examples. We're going to set up some ratios of the side length over the sine of the angle. It's important also to know that these ratios are the same as if we said sine of big A over little a equals sine of big B over little b equals sine of big C over little c. So as long as you keep the signs on the same side of the equation, you're good. And that'll be important in a later question, because we're going to do things as easy as possible. So now let's solve this little triangle down here. And so we have the angle A is 33 degrees, angle B is 105 degrees, and little b, the side length across from big B, is 37.9. The first thing we're going to do is find the measure of angle C. So if you add these two sides together, you get 105 plus 33 equals 138. It's important to remember that all triangles, the angles add up to 180. So 180 minus 138 is 42. So we put our little 42 right in there. That's angle C. That only leaves us little c and little a, and we'll use the law of sines to do each of those. So side length A, we don't know, over the sine of 33 equals side length B, which is 37.9, over the sine of angle B, which is 105. Now here we have a proportion, which you could solve by cross multiplying if you're very comfortable with cross multiplying, which most of you are, or you can say the fraction bar represents division. So we're actually saying side A divided by sine 33. So the way we get the way we get A all by itself is to multiply by sine 33. And when we do that, we get something very simple that we can stick into our calculator, what we like to do. So the first thing you're going to do is make sure, because sometimes these calculators get out of whack, make sure that you're in degrees. And you do that by hitting the mode button and then second quit to get out. Then we're just going to type this right into the calculator. 37.9 sine 33. Make sure you remember that little closed parenthesis there, because otherwise it doesn't give you the right answer. Divided by sine 105. So our answer, rounding to 1 decimal point, like Math Excel has you do, is 21.4. So pretty straightforward. We're going to do the same thing over here. We have little c, which is an unknown. I should probably write 21.4 right there. We have little c, which is an unknown, all over sine of 42 equals 37.9, because that's the one that they gave us, so we know it's right, over sine of 105. And once again, we're dividing by sine 42, so we should multiply both sides by sine 42 to get rid of it on this side. So we plug that into our calculator. Now we're doing 37.9 times sine of 42. Remember that close parenthesis. You don't actually have to put the multiplying sign right there. If it makes you feel more comfortable, do so. Don't do it over here without that close parenthesis, because that changes what it's taking the sign of. And then divide by sine 105, and we get 26.25, which rounds to 26.3. There you go. Okay, now moving on, we have area of triangles, and we're using that same triangle model. And if you know two sides and the included angle, that's the angle in between the two sides, then you can use one of these formulas. And it's 1/2 times the two sides times the sine of the angle. And we're using K so it doesn't get confusing with capital A, which is your angle. So let's do an example. We have the area of ABC. If A is 4.7, C is 12.4, and B is 47.3. So our formula is K equals 1/2 AC sine B. So K is 1/2 times 12.4. Oops. Well, you can multiply in any direction, times 4.7 times sine 47.3. And the way we do that, if you want to put 1/2 in as 1/2, you could put it in as 0.5, or you could divide the whole thing by 2, or you could say 1/2 times 12.4 times 4.7 times sine 47.33. And we get 21.4. There you go. So those are just multiplying. Lots of formulas on here. So then we have the law of cosines, which is used when you know the measure of two sides of a triangle and the included angle. And it's that same triangle again with A and little a, and B and little b, and C and little c. And you're only going to use one of these. That question came up a lot, that you're only going to use one of these formulas to start, and then you can move right back to the law of sines, which I think is a little easier. Okay, so first thing we're going to do is we have big A, little c, and little b. And so first we're going to plug all these in to find little a. So a squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 120. And you can stick all that in your calculator. So let's clear that out. 9 squared plus 5 squared minus 2 times 9 times 5 times the cosine of 120. And we get 151. Now it's important to realize that A is not 151, because that would be a ridiculous triangle to have a side length of 5, a side length of 9, and a side length of 151. But that's A squared, so to cancel out that squared, we have to take the square root. So A square root 151 is 12.3. So then we take that 12.3 for this side length, and we can find b next. So little b is 9. We don't know capital B. And that will equal 12.3 over the sine of 120. Or you can say, I don't like having that on the bottom. That makes it harder for me. So you could say sine B over 9 equals sine 120 over 12.3. So now what you can do is times both sides by 9, get rid of that 9, and we get sine of B equals 9 sine 120 over 12.3. Then, this is where we get a little bit tricky. Anytime you have an angle that's stuck with a sine, a cosine, or a tangent, that's when you use the inverse function. Just like over here, we use the square root to cancel out the squared. We're going to use the sine inverse to cancel out the sine. So we're going to take the sine inverse of this whole thing. So B equals sine inverse of 9 sine 120 over 12.3, which equals, here's how we do this. Oops, covered it all up. Okay, trying to get this so you guys can see it. Okay, you go second, and then the sine button, and that gives you the inverse sign. Don't just put the that one, because that gets screwy. And then once you're in the parentheses, you put the 9 sine 120, close parentheses, divided by 12.3, close parentheses. And we get 39.3. Now, several of my students were saying, oh, then to find C, we have to go back and use one of these laws of cosines. No. Angles add up to 180. Make it easy. So we have 39.3 for angle B. Then we have 120 for angle C, and those add up to 159.3. Then we say, okay, well, those add up to 159.3. The triangle itself has to add to 180. So minus 159.3 equals 20.7, and that's angle C. Okay. If you have all three sides are given, you're going to use the law of cosines to determine the measure of the possible obtuse angle first. Now you might remember from geometry, you might not, that the biggest side is across from the biggest angle. So we're going to put the biggest side over here so that we find the biggest angle. Okay? So we say 40 squared, because that's the biggest side, equals 24 squared plus 18 squared minus 2 times 24 times 18 times the cosine, we don't know B. So then we're going to multiply these out, 1600, because that one I know. And you'd think after doing this problem all day yesterday, I would know 24 squared and 18 squared, but I don't. So 24 squared is 576. Good thing I've got a calculator. 18 squared is 324. And then we're going to do 2 times 24 times 18, which is 864. Cosine B. Now, frequently, people will add these two and then subtract this one and come up with the wrong answer. Don't do that. By PEMDAS, you can't subtract this one from these two because this has to be times by this. It's similar to if you said 864x. It wouldn't be a like term with 576 and 324. So that has to stick with the cosine until we divide it. But you can add 576 and 324, which is 900. And this one, it's a good thing we've got lots of paper. So next, we're going to subtract the 900 because we want that cosine B all by itself. Those cancel. We end up with 700 equals negative 864 cosine B. Then, finally, it's just our number and the cosine B. And these are multiplying, so you can divide by negative 864. That cancels, and we're left with the situation where we have the angle stuck to the cosine. And just like we did over here with the sine, you're going to now take the cosine inverse of both sides, which will cancel this side, and leave it over there. That did not show up. There we go. Now that looks even messier. Sorry, not used to doing math in pen. There. Oh well. So, once again, let me scooch this up so we can see it. Second cosine gives us that nice little inverse part right there. That's what you want. 700 divided by negative 864. And we get our obtuse side is 144.1. That's all there is to it. And now, on to your homework.